We have a problem that is a two-stage cascade refrigeration systems uses an ammonia as the working substance, the evaporator is at -35, and the high pressure condenser is at 1514.2 kPa. The cascade is a direct contact type. The refrigeration load is 90 tons. Determine A, the mass flow rate in the low pressure loop, B, the mass flow rate in high pressure loop, and C, the power required, and D, the COP, and finally E, the quantity of the fluid entering the evaporator. Now, this problem, iba doon sa previous, which is non-mixing yung evaporator ng high pressure loop at low pressure loop, no? This time, this type of cascade system is, mapapansin ninyo, sabi sa problem, it is a direct contact type of a heat exchanger. So it means that the refrigerant at the low stage, so it means that the refrigerant at the low stage and the high stage is mixing. So naghahalo sila when we say mixing. So mixing, so naghahalo, no? So that is the uh, explanation for that one, no? And let's try to label yung mga sinasabi doon sa problem, no? So initially we have the evaporator. So ang sabi doon sa problem, we have the evaporator which is a negative. We have also muna sinabi sa problem, we have your ammonia which is yung refrigerant that is being used by the system, no? And yung ano natin dito, ang evaporator is at -35 degrees Celsius. So let's try to write this one. So ang evaporator natin is at -35 degrees Celsius for the temperature, no? Tapos ano pa, at the high pressure side, sabi doon, so we have 1514. So pressure ang binigay, hindi temperature. So hanapin natin yan mamaya sa table ng ano ito, ng ammonia, since ammonia ang given doon sa problem, no? And the cascade condenser, so yun na nga, direct type. So type ng heat exchangers that is being used as a direct contact, no? And the refrigeration load, so we have the load, so which is yung Q ng evaporator natin, so it is equal to 90 tons, no? So hindi ito weight, compare doon from the previous, this is already tons of refrigeration, so take note of that one, no? Hindi ito weight, no? Tons of refrigeration. From the previous kasi, kino-compute natin that is tons of weight ng mga karne o let's say ng ice or ng isda o whatever na product. So this is already tons of refrigeration. Tapos ano pa, and we are required to determine the mass flow rate in the low pressure loop. So, where is the low pressure loop there? So, ito yung low pressure loop. So, initially, pinapahanap sa atin to. Then, for letter B, the the mass flow rate in the mass flow rate in low pressure loop. Then, the mass flow rate, letter B, mass flow rate in the high pressure loop. No, high pressure loop naman. So, we have here the high pressure loop, no? And so the power required, so how much is the power that is being supplied to your low stage compressor, and the power required to supply at the high stage compressor in order na in order for the system to run, di ba? And then the COP, so that is the coefficients of performance, so hinahanap din. So that will be the equation is the ref effect divided by or useful cooling divided by the compressor's work. So combine yun, no? And the quantity of the fluid entering the quantity of the fluid entering the evaporator. So maybe siguro itong the quantity na sinasabi dito for from the book, it is a percentage. So this is not the quantity, no? So, nagkamali ito dito sa aklat ni ano. This is not a quantity. And let me correct this one. This, for correction, this is not a quantity. So, since the answer from the book, it is a percentage, so this must be the quality. Quality of the refrigerant, no? Quality of refrigerant entering the evaporator. So, ito yon, no? Okay, so we'll try to find out that one later on as we proceed in solving the problem. So let me bring down here the table of thermophysical properties of the refrigerant 717. Now, mapansin niyo dito, we have the 35 degrees. So again, this is far beyond, this is not given to the table, but we are in between negative 36 and negative 34. So we have to do is to interpolate the values in order to get yung value ng enthalpies, no? And also the pressures and other properties which is related to the temperature of negative 35. And also, lagay pala natin mga labels to identify the process flow dito, no? So, I will be naming this one. This is my point 1, 2, 3, 4. So, this will be my ito yung aking 5, this is the 6, 7, and 8 for the process. So, so that we can tag yung other properties which is designated on sa flow of cycle. No? So, we have here, and we have here. So, this is my high stage. So, this is my high stage. And the other one is the low stage vapor compression system. Now, so negative 35, so that will be 0.1, so that is already in form of vapor. So this is now my, this is my enthalpy 1, no? Okay. And so entropy, so that will be in terms of vapor, so that will be my S of 1. Then dito. So if we will try to interpolate, and also we have here the pressures. Okay, so now using the arrow technique, so let's try to build the equation for interpolating uh, the values of refrigerant dito. So we have una, we have here, so that will be negative 36 degrees Celsius, so it will be a minus of, that will be negative 35 degrees Celsius. Then this is all over divided by my negative 36 then degrees Celsius, so minus my negative 34 degrees Celsius, and this is equal, no, equal to, let's say we have here 141, no, so 1414.11 minus my enthalpy 1. And then we have dito naman sa ilalim, that will be 141.11 minus my 1417.23. And this is equal now to my entropy also. So that will be 6.694 minus my S entropy in between, sa gitna yan. And this is also sa ilalim 6.1694 minus 6.339. No? Okay, so computing yung value na ito, so we have 0.5. Now let's try to manipulate yung value and to get the value of enthalpy 1, no? So I have here, so this will become 0.5. So multiply yung value na ito. So that will be equal to, so this is multiplied by 1414.11. So minus this one 1417.23. and this is equal to 1014.11 minus my enthalpy 1. Now to get the enthalpy 1, so transpose nyo yan. So we have 1014.11, so that will be minus my 0.5 times 1014.11 minus, that will be 1417.23. Okay, so using your calculator, so we have the value for that one. So this is equal to that will be 1415, no? 0.67, so that will be kilojoule per kilogram. Okay, so let's summarize natin dito ang every point. No? So that will be enthalpy 1. So this is a low stage vapor compression systems at low stage. So we have enthalpy 1, that will be negative 35 degrees Celsius. So that will be from the table by means of interpolation. Now since enthalpy 1, then we have ang isentropic compression from point 1 to point 2. So we need hanapin din natin yung isentropic compression value for that one. So let's go back here. So we have again, so taking this one, so that will be 0.5, no? So we have 0.5, and this is equal to the value nito. So let's transpose this one. So this will be 0.5, that will be multiplied by the entropy, which is 6.16. That will be 94 minus that will be 6.1339. And this is equal now to 6.1694, and we have your entropy 1. To get your entropy at point 1, so let's transpose this one, 6.1694 minus yung value na ito, we have so we have your S sub 1 is equal to, this is equal to 6.15165. So that will be kilojoule, kilogram, and that is Kelvin. Okay, so for the value, so that is from the interpolation value. So from negative 35 degrees from table and by means of interpolation. Okay, so from here, ang pressure ng negative 35, so it is in between, di ba? So let's go back to the, let's put it in the pressure and enthalpy diagram, pH diagram. So 0.08, so it is somewhere here. So decay siya sa point negative 34. So mga 0.0 o mga 0.08 o 0.09, somewhere dito pumapatak yan, no? So let's try to draw the line representing yung part na yan, no? So we have yung part na ito. So representing the pressure, no? So somewhere here. Okay. And this is my this point 1. Ito yung point 1 ko. Okay. So this is my point 1. No? Now referring yung enthalpy niyan, so we have here. So kanina yung nakuha natin, that is 1415. Okay, so this is equal to 1415. So we have your enthalpy 1, which is equal to 1415. So this is kilojoule per kilogram for the enthalpy at point 1. And ang entropy is 6.15. So we have here the entropy, which is the 6. So let me try to adjust this one. So this is my entropy 1, that is 6.15. No? Again, let me check. So kanina, that's the 6.15. Okay, 6.15. Then we have isentropic compression, which is parallel din dito sa line na ito. Yan. Okay. Now, ang pressure discharge, we don't, let me check on the schematic value. So, ano ba ang value natin? So, from here, let me review the problem. So, ang meron tayo is only the condenser pressure. And we have the direct contact. We don't know what is the pressure in between dito sa direct contact heat exchanger, no? But this can be computed, no? Pwede nating gamitin yung para makuha natin yung pressure niyan is using the intermediate pressure for minimum work, no? So, parang yung heat exchanger mo dyan, ng direct contact, serve as already parang ano na, parang flush tank ang nangyari sa kanya. And in order to get yung intermediate pressure here, so we need to compute yung the square ng dalawang high pressure and low pressure side, no? So for my intermediate pressure, so this will be equal to the square root, no? Square root of that will be square root ng pressure na high pressure natin at low pressure. So referring here, so we have the pressure ng 0.1 at saka ng 0.6. Okay, so let's try to solve that one. So that will be pressure 1 times my pressure at 0.6. Then, so substitute natin yung values dito. So we may able to get yung values ng pressure which is in between. So pressure 1, so again, so ang pressure 1 natin pala dito, referring here, wala tayo palang so that is by means of interpolation, so we forgot to get yung value ng intermediate pressure, so we need to solve that one. So let me equate, no? Equate natin ito para makuha natin yung intermediate pressure, the intermediate pressure doon, no? So let me equate this one. Okay. Then para makuha natin intermediate pressure. So we have here the pressure 1. So using the arrow technique, no? Okay. So we able to get yung intermediate pressure. So that will be, we have 0.08845. So that is minus p sub 1. And this is all over 0.088, that will be 45 minus 0.09. So 9795. So that will be 9795. Okay. So since we have already 0.5, so we can directly solve this one. So from here, so let's try to rewrite it dito. So this is equal to 0.08845 minus my p sub 1. Then this is all over, that will be 0.08845 minus, that will be 0.09795. So transposing that one, we have 0.5 times 0.08845 minus 0.09795 minus, that will be 0.08845. So this is equal minus my p sub 1. Then finally, we have your p sub 1, which is equal to 0.0888, that will be 8845 minus 0.5, 0.08845 minus 0.09795. So, yung piece of 1 natin, which is equal. So, ito ay equal to 0.0932. So, this is the unit of megapascal. Okay. So, let me go back doon kanina. So, ang value niya 0.0 ano na, no? So, let me try to adjust this one. So, which is much closer to 0.9. So, adjusting that one. Okay. So, we may able to see that we are in closer values, diba? So, we have already the pressure one. So, substitute na natin dito. So, we have, that will be 0.0932. That will be megapascal. Times yung value ng pressure at the high stage, which is 1,514.2. So, this is multiplied by 1,514.2. This is also in terms of megapascal. So, we have your intermediate pressure. Okay, so correction nga pala dito, no? So, hindi ko napansin. This is, kaya that's why, ang taas pala masyadong value ko. So, this is in, palang given sa problem. So, this is in terms of the unit of kPa. So, let me try to convert yung ito. So, this is equal to, ano pala, no? 1.142. So, in terms of megapascal. So, yun pala ang dahilan bakit masyado mataas ang intermediate pressure. So, let me correct this one. So, we have ito. So, let's change this. Okay, so, we have a value of 0.3756. So, that will be 566. So, that will be megapascal for the intermediate pressure. Now, looking to the table, so hanapin natin yan. Let's plot that one dito. So, 0.4, 0.1375. Now, for my pressure, 0.3756. So, lapit siya doon sa 0.4 and 0.4. Ito, no? So, somewhere here, yung pressure na yun, which is my pressure. So, let me change this one. The color, same, no? So, dito siya banda, diba? So, somewhere here, yung value ng part na, ano na yun, intermediate pressure natin. Okay. So, let me adjust this one. So, this is 1, and this is my point 2. Now, to complete the cycle, so, I have ito, diba dyan? So, that will be 2, and I have my 3, and then, meron tayong 4 dito. So, we have the ref effect 4 to 1. So, for my point 2, I have my enthalpy 2. So, this is equal to, so this is 1,000. So, this is around 1,500. So, this is 1,400. 50 and 50. So, this is 1,580. This is kilojoule per kilogram for my enthalpy 2. Then, for my enthalpy 3, I can estimate this one using this also directly na natin estimate yan. And we can plot this one here. So, I have my enthalpy 3, which is my equal to my enthalpy 4. And this is equal to, so this is already 200 now. And starting from 0, we have So this is around, so this is, we have 0, 50, 100, and then 150. So maybe around 160. That will be kilojoule per kilogram. So double check yan if we have the range noon kasi ito 0.375. So let's check doon sa table that is already wala pa dito. So let me bring that one, yung table ng refrigerant natin. Okay. So bringing down the refrigerant table. So ang pressure is 0.375. So makikita nyo dito 0.375. So yun, this one. So this is 368, 398. So pagitan nito and ang corresponding enthalpy niya sa liquid side, no? So yun, meron pala tayong, this is the range in between 181.54 and in between 190.76. Now, to be exact, so pwede natin itong i-compute, no? So, pwede natin i-compute ito again by means of interpolations in order to get the exact value of your enthalpy at liquid in between, no? So, let's try to do that one. Okay, so we have here liquid yan, no? So, let's try to interpolate here. So, we have negative, that will be negative 4, that will minus my temperature would be Ti. So this is all over. Okay, and so that will be negative Ti. Then ito ay magiging negative 4 minus my negative 2. And this is equating to 0.36880. Okay, and it will be minus my 0.37566. Then sa ilalim we have 0.36880 minus value na ito, that would be 0.39819, and equating this one sa value ng enthalpy. So I have 181.54 minus my enthalpy 3, and this is all over 181.54 minus 190.76. Now we have here transposing, equating that one. So we have your enthalpy. So let's try to solve this one to get enthalpy. So enthalpy natin, it will be equal to 183. That would be 69. So that would be kilojoule per kilogram. Or we can say this is 184. So that would be kilojoule per kilogram. So let's try to compare that one do sa estimated value natin. Okay, so yung unang estimated value natin is way back malayo, no? So it's much better pa rin ang ginawa ko ay interpolate to get the exact value. So I will be changing this one. So let me try to change this one to yung interpolate value natin, which is 100. This is 183. .69. So that will be kilojoule per kilogram. So next, we're going to plot yung high pressure naman, high pressure side. So that will be pressure niya. So that is 1.514. So referring do sa table, so that is 1.514, 1.5142. So that will be the pressure. So let's try to check that one. So 1514, so it is in between ng 40 degrees at saka 42. Yung 15 1 yung 1.5142. So sa pagitan ni ng 1.51 tsaka 42, pagitan nito ng 38 tsaka 40 degrees. So meron tayo ng pressure ng condenser. We don't have the temperature, so what we're going to do is to interpolate para makuha natin yung enthalpy 7. So by using yung arrow technique ulit.